Right, so this is lesson 4 in the 5.3 Metals and their Reactivity series lessons. So today we're going to be looking at the economic viability of metal work sites and then looking at a couple of little key points in the specification that don't really fit anywhere else. So if you're using your class notebook, this bit will already be in it. Okay, so today we're going to look at outlining the factors that affect the economic viability and sustainability of extraction plants. Apply this to GCSE questions. We're also going to do a little bit on alloys and transition metals. So keywords, remember, scientific literacy is really important. What I want you to do is pause the screen and have a go at these 4 questions by here. Okay, so make sure you correct these answers. What is the process used to extract iron? That's the blast furnace. What are the raw materials needed to extract iron? You've got coke, which is your source of carbon. You've got iron ore. You've got limestone, which removes impurities. And you've also got a source of oxygen. What are the metals? How are metals found on Earth? They're normally found in ores. Really unreactive metals such as gold and silver tend to just be found on their own, but most of them are found in ores attached to another non-metal compound. Name the ore that iron is most commonly found in. Iron oxide is normally iron 3 oxide, and we'll talk about that in a minute because iron has the ability to exist as a 1 or a 3. A 1 or a 3? A 2 or a 3, sorry. So, explain why these things are important to the economic viability and sustainability of an extraction plant, okay? So we've looked at the blast furnace. Okay, we've looked at the blast furnace and thinking about these things. Why does it need to be near a power station? So thinking about being near a power station, I'll fill this one in for you and then I want you to have a go at a couple. Obviously, it requires a large amount of heat, this process, okay? Heat only comes normally from power or burning a fossil fuel. So you need to be close to a power plant so that you can get access to your electricity or however you're going to heat it, okay? Think about the rest, pause the screen, and then in a minute I'll come back and share the answers. Okay, so here are a couple of answers that I came up with. You might have come up with other ones. So another important factor is to be close to the coast so we can bring in the iron ore from other countries and import. Close to railways and road links to export the iron so that we can send it to other parts of the country to build whatever we need to build. Close to an area of population, we need a workforce, okay? And they're not next to settlements or areas of natural beauty. We don't want to pollute them areas. So this often comes up as a 6-mark question. It says, what important factors and why? So we've got it in your book now. What important factors and why? Okay, and it comes up often as a 6-marker. I would put it near a power station because I need a source of heat. I need to be able to burn fossil fuels to make energy, okay? Etc, etc. You've got more than enough there to write a 6-marker. Okay, so next little thing we're going to look at is something called transition metals. So we spent an awful lot of time in chemistry looking at group 1 and group 2. Ignore hydrogen because hydrogen is always normally there, okay? And then this is a bit of an old-fashioned periodic table in that it's done all the groups. Now, we don't normally do these groups here in the middle, and then we start 3, 4, 5, 6, 7, and then 0. So that's normally how we do it. And these ones in the middle here, they're known as transition metals, okay? So they're the transition period between group 1, group 2, and group 3. And obviously you've got your little step here, whereby these ones here tend to be, and these ones here tend to have metals and non-metal properties, whereas these ones here are definitely metals, okay? And then you've got your non-metals. So the transition metals are the bit in the middle between group 1, group 2 and group 3. So these are kind of things that you need to know about transition metal. Pick out the ones that stay in your mind. Don't write them all down because you're never going to remember them all, but pick the ones that stay in your mind, okay? So they're all magnetic. That's a nice easy one to remember. Every single transition metal is magnetic. They are all solids at room temperature apart from mercury, which is a liquid, so that's the only one in the middle that isn't a solid. They can all be bent into shape, so they're malleable. They have quite high density, high melting and boiling points, okay? Ductile, have lots of uses, good conductors of heat and electricity. I would be expecting you to write in your notes at least 4, okay, to remember. Don't write this one because they're not going to accept that in the exam, found in the middle of the period table. That is true, but they're not going to really accept that as an answer. So pause it, pick the ones that you think you'll be able to use and remember. Okay, so some transition metals have the ability to form coloured compounds, okay, and you have to remember these three, so you need to learn them, okay. So they might ask you, and sometimes questions come up, okay, copper has the ability to form a blue compound, whereas iron 2 is pale green and iron 3 is brown, okay, so you just have to learn them. There's nothing more to it than just learning. Okay, another key definition that you need to note down or have in your minds is alloy. So an alloy is made by mixing two molten metals together. And then there's a little bit of a picture of a metal, because we know that metals are positive ions surrounded by a sea of delocalized electrons. So they get rid of their outer shell electrons, so they can float. That's why they can conduct electricity, metals, because it can pass on the electricity through its delocalized electrons. Okay, when you mix molten metals together, they distort the layers, making it harder for them to slide over each other. So alloys are often harder than just pure metals because you've got a mixture and it distorts the layers. In a normal metal, you've just got layers on top of layers of the metals with your delocalized electrons. What you might find then is that an alloy, which looks a little bit different, will kind of slot in there. So it distorts the layers. They aren't even layers anymore, which makes them harder, which then again, they have their use. Big one for us is steel, okay? Steel is an alloy of iron, so it's a mixture of a metal, iron, and then something else. Often we mix it with carbon, okay? And then they're different, how much carbon you add or what else you can add, because you can do chromium and nickel, depends on what it's used for, okay? Other ones are things like rose gold. That's a mixture of copper and gold, so used in jewellery, but that's an alloy. There's loads of different ones, but the big ones are steel that you need to know about, which is normally iron mixed with carbon. Final little activity that I'd like you to complete is I would like you to have a little bit of a go at researching this, okay? I'm not going to put the answers up till later. Researching it. So what are the properties of iron and what are the uses of iron, okay? I'm expecting 3 properties. And by properties, I mean high density, strong, okay, resistant to high heat. So they're their properties. Uses, iron tends to be used in bridges, large-scale structures. So I'm expecting you now to fill out the other 3, okay? You have to be able to answer them and recall them, okay? So make sure you submit your work when you're done. Thank you.